we will be seeing what's in iOS, right? So like I said, it's a hierarchical structure. The lower layers contain the fundamental services and technologies, and the higher level layers build upon these lower layers and provide more sophisticated services and technologies to the user, to the end user. So let's see each of these layers in detail. So the core OS is basically, it comprises of the OS X kernel. Now the kernel is, it's like a typical kernel, right? It does your I/O reads between the top layers and the CPU, memory, and other devices. So it's at the most basic level. It communicates with the CPU and the devices. And Mac 3.0, this is the basis of your iOS and the OS operating system. And BSD are basically Berkeley sockets. They're used for inter-process communication and security, power management. So core OS is, it takes care of all these. Power management, keychain access. Keychain access is basically, if you have used your Mac, it's the password management system used by your Mac and generally the OS operating system. And it syncs passwords. Basically, it syncs passwords across devices. It stores passwords and certain other information on the cloud, so you can access them across devices. Certificates, file system, and Bonjour. Bonjour is used for address assignment, service discovery using DNS. So, your applications like iTunes, they use this basically to do any kind of service discovery, to find shared music. And then iPhoto uses it for shared photos, to discover shared photos, and so on and so forth. So all these are, they comprise the core OS layer. And this layer is built from the low-level features that most other technologies are built on. And yes, like I said, if you need to explicitly deal with security or communicate with external hardware, then you need to use the frameworks of this layer. And again, the SDK, the iOS SDK has frameworks for which have built-in classes for doing all this for you. So so the SDK is pretty powerful in that sense. Then come the core services, which is your address book, your networking, file access, then your database, your SQLite, core location services, net services, threading, preferences, URL utilities. So these core services are, that the core service layer takes care of these fundamental system services for apps. And key among these services are the core foundation and the foundation frameworks, which define the basic types that is being used by all apps. So the foundation framework is, it contains classes such as NSString, NSDate, NSObject. NSObject is the most basic object class that you will use, and all other classes extend from the NSObject. So this is the root object, this is the root class. And all these classes are in the foundation framework. So if you see, I can just show you Xcode. So say if you see here in your supporting files, let's say supporting files, if you see, yes, here, the UIKit.framework. Yeah, you see all these header files. So these are the classes which comprise the iOS SDK. So this is like one of the frameworks. So if you would want to add it, then you can go here and say you can add a framework, and under the linked frameworks and libraries, I'm just adding it to show you, to give you a glimpse of one of the frameworks. Say for example, the core foundation framework. If you add it here, yes, and then it comes here. So what I do is I try to drag it onto the supporting files here, under supporting files, and in core foundation you will find all these classes, CF array, right? And the interesting part here is that the core foundation is written here. So if you want to add one more file, one more framework, let's add the foundation framework. Yes, so if you see here, the ns object.h, this is the root class, and all other classes, if you see NSLaw, all the other classes are extended from the NS object. So like I said, the APIs are such that you can go through the source code and it's pretty straightforward. You do not have, they do not reference more inner classes, or even if they do, it's maybe, up to 2 or 3 levels at the max. And it's easy for you to, a programmer, to navigate through that structure. Okay, let's see some other class, say, yeah. So you see, these frameworks are a part of core services. And this layer also contains individual technologies to support features such as location, iCloud, social media, and networking. So if you would want to integrate with, say, Twitter or Facebook tomorrow, if you would want that integration to happen with your app, then you would be using frameworks from this layer. Yes, and of course the media layer, which is used for audio, video. And the framework that we use here is the AV framework. It's a very, very powerful framework. It has core audio, audio mixing, audio recording, video playback, OpenAL. It supports various formats, PNG, TIFF, JPG, PDF. It has chords for 2D animation, core animation. It also conforms to OpenGL standards. So you could implement wonderful multimedia experiences in your app using this layer. And this framework directly interfaces, or it accesses the device features using this framework, and you can make full use of these features in your apps. And then of course you have Cocoa Touch, which is the topmost layer, and this contains key frameworks for UI related features. So multi-touch, gesture recognizers, core motion recognizers, the view hierarchy. Like once we start with app development, we will be showing you what is exactly the hierarchy of the view which is presented to the user. So you have a window, and within the window you have views, and then the views also have a hierarchy. Like there is a navigation view, there is a web view. So all these how to be presented to the user in what order is managed by this layer. And it also has controls, various controls, UI controls, alerts, localization specific controls, web view, the map kit, the image picker, which it picks from the camera or the photo library, and of course the camera. So the Cocoa Touch, see this layer, at every layer you also had this at the core services and at the core OS, right? But this Cocoa Touch is specific to the user input. So when the user clicks on the camera, then you have a specific action which has happened and the camera is invoked. So this layer takes care of that. And using frameworks in this layer, we define the appearance of our app. This is like our UI builder and our interface builder basically. And we use the frameworks in that when we are building our interface, the face of our app. And not only that, they provide the basic app infrastructure and support for key technologies such as multitasking and many other high-level system services. Okay, so now in a nutshell, we'll see what are the platform components. What are the components of this iOS platform? So if you see the tools, they are the instruments and the Xcode ID. So you would, to begin with, you would not need, say, an iPhone, because the simulator within the Xcode takes care of that. I can quickly show that to you here. See, if you see here, then this is the simulator, right? See, this is the project, Hello project, and if you go here, iOS device, this is actually, so if I plug in my iPhone with the Mac, then here it will recognize it at this section, it will recognize the iPhone. It will say, for example, it will say Chitra's iPhone, right, because that is the registered name of my device. But as of now, since no device has been connected to my Mac and in turn my Xcode ID, so I just get a blank iOS device, which means nothing is connected. But below that, if you see under the iOS simulator, you have so many versions of the iOS devices. You have iPad 2, iPad Air, iPad Retina, and iPhone 4S to 6. And you also have the resizable versions. So basically the simulator will simulate all these devices for you, and you can see how your apps will run if they were directly connected to these devices. And the simulator is a fairly good representation of what happens in the actual screens, actual device screens. So it's a very, very good, powerful, helpful feature when you are developing apps and you would like to quickly test them in different devices. Say when you're creating the user interface and you would want to see them across different devices. So this is like a ready recorder. You do not have to, gather all your devices and plug in and plug out. You can easily use the simulator for that. So that's the beauty of this. But that apart, when we come back to our platform components, we need our Xcode ID and then the instruments. The language that we need to know is Objective-C. Like there's no going around this. You need to understand, you need to know this language, Objective-C. And frameworks, to build any kind of meaningful apps, you need to use the foundation framework, the UI kit framework. And then as you start building more sophistication, or you start using more features into your apps, you will be using the appropriate frameworks like MapKit, Core, Motion, Location, Navigation, etc., Core Data. Yes, and the design strategies are MVC and Delegate and Target Action. So if you have come from Java background or any other object-oriented programming background or application development for that matter, then you may be slightly aware of this. If not to worry. While we are developing our apps, we will be looking into detail about these design patterns and strategies, and we will see how, what is the significance and how it is being used in iPhone. So this course does not assume that you know these strategies, but if you have already come across them, and it is very similar to what you have used in other languages. Right, so design strategies. So now we come to the basic design strategies that we will be using in iOS app development. And the first and foremost is the MVC, the Model View Controller. Now all iOS maps use Model View Controllers. And what is this MVC pattern? Basically, it's the link between an app's data and its user interface. MVC is, so this design pattern is basically used to separate the three layers. It's, it's designed in such a way that there is loose coupling between all these three layers. So what that does is it changes in, say, the underlying data structure will have very less impact on the view, the user interface. So that's the advantage. And also, since the controller it controls all the interactions between the models and the views, there is no clutter, no chaos, and it's easier to kind of visualize the different interactions between the three layers. So it's a very modular and a very graceful approach to application development. And if you have come from, say, the days of when web application development started and when it matured, as it matured, if you would see the days when we were making applications in JSP, for example, Java server pages. It's a very powerful technology, but one of the disadvantages of JSPs was inline coding. So what used to happen was, in those days we exclusively used HTML and JavaScript for designing the web form fields and the UI elements on the web form. Now this I'm talking about is web application, but just to give you a context of MVC and how it translates to the mobile scenario. So what used to happen in JSP was we had HTML and JavaScript code, and at the same time in the same file we used to also have calls to the database in terms of stored procedures or function calls to the database in using structured query language queries. So not only would this make the file very it used to run into hundreds and hundreds of lines of code, but see tomorrow if a table name change or something very small as say the field length or the field length of the underlying column changed, the developer had to actually run through all these files and see where was that particular query and change it there. So it makes it very difficult in terms of scaling your application or changing the structure. Change is a part of the IT, your business landscape or your systems, right? So tomorrow if you need to accommodate huge data, you need to you've done some kind of normalization, your database manager has done some changes, so your applications have to reflect that change, right? Otherwise it will crash. So in these scenarios it became very, very difficult, and that's just one example. There could be many other triggers for change. So and that's the reason why it's very important to have the loose coupling between these three basic layers of application. So the model is your where your data is, and the view is your interface, and the controller in MVC controls both these, the interactions between these. Now how it does is what we'll see. Okay, so let's just imagine these three different entities here. We have divided them into three camps. So we have your models here, you have your views, and you have the controller in between. So what is the model? Like we said, model it's about the application. It's where your business logic, your application rules are present, and it's not about the display. And the controller is the model representation to the user. It's basically the UI logic. And finally, the controller, the view acts as the controller's minions. So the view does not do anything on itself, but the controller controls it. And the whole design pattern it's all about managing the communication between these three camps. And controllers can always have direct communication with their model, and they will be doing that. They need to communicate with the underlying data model, and at the same time they will also be communicating with the view, with the user interface. So basically the controller is the one which is talking to either of these two cams. And the way they do it with the view is by a term called as outlet. And we will use this when we are, developing our app. So we have the main interface builder, which is our view, and we will be tying it with a controller, which is a class file, and we will be assigning an outlet from the user interface to the controller. And this is how your communication will happen. And the most basic requirement of this design pattern is that the model and the view should never have any direct communication with each other. All communication will happen via the controller. So this is like the basic, in a nutshell, this is what MVC is. So you have, you have three different cams: the model, the controller, and the view. The model corresponds to the underlying data. The controller has the logic, and the view is the user interface. And communication happens between the model and the view via the controller and not directly. Okay, so what we saw here was we mentioned the outlet, which will be used by the controller to communicate with the view. Now, is the reverse possible? Can the view communicate with its controller? Now, communication is blind and structured, which means when the view communicates with controller, the model does not have any idea about this. And yes, sometimes the controller can drop a target on itself. So it need not come from the view, it can come from within the controller itself. And when you design an outlet, it's you tie the view to the controller. And then based on, the user interaction, the controller hands out an action to the view. So for example, if I have, say, a button on my view, say this is my user interface and I have a button here. Okay, so what I do is I tie this button to my controller file using an outlet. And what I do is I say the action that has to be captured is the click of a button. So that is how I, as a programmer, I will tell my controller that when this action happens, there are certain things to be performed by the controller within the controller file. So that is what is the significance of actions. So basically it means the controller has handed out an action to the view. And who does this action? The user. And this action is then sent to the controller when by the view. And sometimes what happens is you have different points at which the action will occur. So that has to be synchronized by the view with the controller. So there can be instances where the button was clicked or will be clicked or should be clicked. So there will be three different cases. And if you see in your code, like say, let's take a storyboard and say, so this is your template. You will get different templates for iOS and different templates for OS X. So iOS is basically for developing apps on your iPhone, iPod Touch, your iPad. And OS X is for the App Store or the Mac. So let's select iOS and click on application. And let's say single view application. This is the most basic kind of an application. And click next. And here we can say put in a name called as demo. Now here if you see the organization name, this is what you will configure based on your company name. And this then becomes like, the package structure in Java. So it will be appended by com dot and then the organization name. So that becomes your organization identifier. And all this information will go into your bundle. So when you are deploying this app, this information will come here. It will be an organization identifier basically. And the language is Objective-C. right? But you also have the option of Swift because this is the latest version of Xcode. Don't worry, just hang on here. I'm just showing you this to explain MVC, but we will be walking you through the installation of Xcode and we'll start from there. But very quickly, here by default it's iPhone, but you can also go to iPad or you can do universal, which is both. Go to next, and this is like my default structure. Sorry. So it says demos are already there, so let us say demo Edureka. Click on next, create. Okay, so what I wanted to show you was when you do this basic project creation, you have a main.storyboard, and this is your interface builder. This is where you will be designing your UI elements. Now how you do that? You have these widgets out here. You have a view controller, you have a navigation controller. So by default, if you say UI view, so a view provides a structure for drawing and handling events. A UI view object claims a rectangular region of its enclosing superview and is responsible for all drawing in that region as well as receiving events that occur in the region. So for all practical purposes, right now just assume that this is the canvas on which you will be drawing your user interface. Okay. And then now let me say I put a button. So this is just a basic button, right? Now this is my UI. Now I need to tie it to a controller according to the MVC pattern that we need to use in iOS. So if you see they're already by default, there is a controller class which is the view controller. Now how this gets tied to my storyboard is that here, when I click on this, you see this whole controller has been highlighted. This whole section has been highlighted in blue, right? Now, if I see the corresponding class file, it says view controller here on the right-hand side. I hope everybody is with me here. So on the right-hand side, I see a view controller class, which is nothing but these two class, this class here and these two files. Now, view controller.h is the header file, which is the interface, and .m is the implementation, corresponding implementation. So all code goes inside this, and this is the header file, which has just the properties and the declaration of the methods. Okay, right now both are empty. And right now what has happened is there is a button on my UI, on my interface, and the whole interface is tied to the view controller class. Now, when we mentioned about outlets, I will show you how to tie this button to this class, to my controller. So what we need to do here is click on this, you see this tuxedo icon here on the top right hand side. Click on that and it will open two panes. And here you need to select the interface, not .m but .h. And then you click on the button, and with your left hand, with the other hand, you press the control button on your Mac keyboard, and with your right hand side you just drag this and you take it in between the interface body. So it says insert outlet action or outlet connection, and when I release it, it shows me this pop-up which says, which asks me to define what is the connection type. So I can either show it as an outlet or as an action. So since it's a button, it's an outlet, and I will name it as a button capture. Let's say it's a button for a camera and we are using it to capture an image. So let's just click on connect. So this is how I get tied on to, my view gets tied on to my controller, the first thing is you have to assign a controller to my view, and then for a specific UI control, you tie that to the controller using this property, the outlet property, using the IB outlet class. So now that we do that, then the controller takes over, and the controller sets itself as the views delegate. So it starts acting on behalf of the view, and it interacts with another class, another controller, or with the underlying model based on the app design or the app logic. And this delegate is set via a protocol, so it's blind to the class. There is it's not it's transparent to the other elements. And very simply, views do not own the data they display, so they come from the controller. So if they need the data, they have a protocol to acquire it, and this happens via the controller. So it's done in a methodical fashion. When you click on apps, when you start building apps, you would be doing it in a methodical manner, but the underlying architecture or the underlying design pattern is what you need to understand as and the benefits for achieving it in a particular manner. It's it's not enough that that how to tie it, but you also need to know the reason behind it, why it is done. It's what is the reason and what are the advantages behind this architecture. So in other words, controllers are almost always a data source and not the model for the view. As far as the view is concerned, all the data is coming from the controller. It's blind to the underlying implications of where the controller gets the data from. And controllers interpret or format the model information for the view. So any kind of data formatting or any logic, business logic that has to be done for the data to be represented to the view is done in the controller. So this is where all the action happens, and this is where it is presented in the view, and this is where it comes from actually. Now the other way, can the model communicate directly with the controller? Yes. So the model again, so coming back to the loose coupling that we need to maintain, the model should also be UI independent. So irrespective of what the view is, the model stays the same. And hence, yes, but say in a situation where the model has information to update, or some other information, then what happens? What happens in that case? So in that case, what it does is it uses a broadcast mechanism, a notification, and like a radio station. So all listeners which are tuned to a radio station, when it broadcasts something, they pick up that message, right? So similarly, controllers or other models, yeah. So that is the beauty of MVC. You can scale it to include other MVCs, and the rules remain the same. So controllers that tune into that particular model will be alerted in case of, they will be notified in case of an underlying model change, and that's how they will come to know about the change. And yes, a view might tune in, but not probably to a most certainly not to a model station. So it will tune into the controller. So these are the basic protocols or modes of communication, or the basic rules in this pattern. And now that we have a basic set of MVC and we have implemented them, we can combine different MVC groups. Like I said, we can have different MVC groups to make more complicated programs. So a typical diagram showing multiple MVCs working together. And everywhere in all these individual MVC blocks, the rules remain the same. So for example, here, like the color coding remains the same. So the blue clouds that you see are the controllers. So within a particular MVC unit, like here, the communication happens via the controller. So the outlet gives message to the controller, and the controller responds back to the view. Similarly, the controller also communicates with the model, and so this controller also listens to other controllers. So then it's like a hub and spoke. So you have different controllers talking to each other and also to their individual models and UIs. Now, there are also cases in the business landscape when you have multiple systems. You have data stores, because these are all loosely coupled. Data stores can also communicate with each other irrespective of the controller. You do not need a controller to have a database level communication between two data stores. That happens. But any type of communication within an application that follows the MVC pattern will have to happen via the controller. So that is the basic rule of thumb.